Hello friends, welcome back. In this session, we will understand quickly what federated learning is all about. There's a lot of discussion on this topic and this is a very important area too. We will understand what exactly is federated learning in this session. Very simple, federated learning is heading us towards safer AI. It's a way or a technique you could say to train the AI models but in a much safer way. In this approach, the AI models shall be trained in such a way that no one would be able to see or touch the data, and it ensures privacy and safety. You get the AI models trained without somebody touching the data or knowing the data, and that's the best part of it, and this ensures safety and privacy. It is a real innovative approach, and we need to see an example to understand this. Approach is very simple. It is a machine learning approach which allows a model to be trained across multiple decentralized devices or servers holding the local data samples without exchanging them. I stress the point here, without exchanging them. The fundamental idea or logic behind federated learning is to enable machine learning models to learn from the data that is distributed across multiple devices or different locations while keeping the data localized and private. This ensures privacy and safety. We will see steps that are involved in this federated learning. The first one is initialization, where a global model is initialized on a central server. The second step is model distribution, where the global model is sent to individual devices or servers, each with its own local data set. They have a local data set at their end. And then comes the local training, where the model is trained on each device using the local data which is already available locally without sending the data back to the central server. So your data remains with you and you get the training accomplished as well, and you do not have to send the data back to the server. This step involves multiple iterations to improve the training accuracy and the performance. The next stage is model updates. After the local training, the model on each device generates an update or gradient based on its local dataset. And then aggregation happens, where the updates or the gradients from all the devices are sent back to the central server, where they are aggregated to update the global model. So the global model gets updated. Now, from the model distribution till the aggregation, the steps will be repeated iteratively to improve the accuracy and the global model's performance. That's it. What are the advantages that you carry here? Privacy. The raw data does not leave the local device. It stays right there. Federated learning this way helps to address the privacy concerns, and this is a great solution we all trust. Decentralization. The approach supports models trained across a decentralized network, making it very suitable for application where data is distributed. That's a very important advantage. Reduced communication overhead is the next advantage, where the federated learning approach minimizes the need for large-scale data transfers, as only model updates are exchanged rather than data being exchanged. That's a very important advantage again. We'll take a simple example. We are going to take two hospitals as reference here, Hospital A and Hospital B, sharing information for improving a medical prediction model. The first step, as I told you, is initialization. Both hospitals start with a shared initial medical prediction model. Then comes the model distribution. The model is sent to Hospital A and Hospital B. Local training is the next step now. At the Hospital A, the model is trained using its own patient data, focusing on the local data patterns and characteristics. Parallelly, Hospital B, also the same process happens. Now, model updates is the next step. Hospital A and Hospital B generate updates based on the local training, highlighting the medical insights specific to their patient populations. And aggregation happens now. The model updates from both the hospitals are sent to the central server, where they are now combined properly to create an improved global model, and that is the best part of it. And you will have to repeat the steps until you get the best of the accuracy as you expect. So when you follow this approach, both the hospitals contribute to the improvement of the shared medical prediction without sharing any sensitive patient information. This is federated learning for you. Another simpler example I can give you here. You and your friends all want to learn karate, but you don't want to share your secret training moves. Federated learning will help you in accomplishing this task. Each friend will practice alone. You all are going to practice karate drills on your own, and whatever you know already you will practice, and this keeps your secrets all with you. Now share only the improved ideas, share only the improvements. After practicing, everyone shares the improvement tips, not the entire routines. You might say that focus only on this area, focus only on kicks, focus only on moves. So you are sharing only the improvement aspects. Now the teacher collects all these tips together and he creates a master lesson, and then he gives it to everybody, where we are learning together, growing together, without revealing everybody's practice routine or the secrets. This is what is called federated learning, and I hope I made it clear. If you have any questions, please go ahead and type it in the comment section. I'll be happy to reply. If you like the channel, please subscribe. Thank you.